First thing, if we call any acid, if we just designate any acid that we have here as HA, just any acid, and we say this acid dissociates into the salt of the acid or the conjugate base A minus and H plus. Now, we just did that with these other acids. We really did. This, we said here, what we're doing here, if you look back at this previous chart, we said here's beta-hydroxybutyric acid dissociating into beta-hydroxybutyrate and a proton. Well, what we're doing in the equations we're going to use now is we're just designating this as HA, the associated form of the acid, and then A minus would be the dissociated form of the acid plus a proton. That's what we got here. So for any acid, we can write this equation. We can write the Ka, and Ka stands for the dissociation constant for an acid. We write the products of the reaction over the reactant. So we write the acid as the protons times the concentration of the salt or the conjugate base, either one is a correct term, over the concentration of acid in solution. And for a weak acid, because these things don't dissociate so much, and this is for pure water here, that this upper part here is always going to be small compared to the denominator. So these Ka's for these compounds are always 1 times 10 to the minus 4th, 1 times 10 to the minus 6th, something like that. Now that's the dissociation constant. And if you look at that, it's got 3 unknowns in it. This is a constant. If you know if you know the constant and you know any 2 concentrations here, like if you know the pH and you know HA, you can determine A minus. If you know A minus and HA, you can determine H. It's just a mathematical equation. It allows you to determine, if you know some of the properties of a solution, you can determine the concentration of the acid or the salt of the acid. Now, from this thing, and we're not asking you to do this, please don't sit down and do it yourself, but I just want to tell you, from this equation, you can take the log, a negative log of both sides, and you can end up with this equation here, which you need to sit down and memorize for this course. You can forget it after this course is over probably, but while you're in this course, you better know this is the Henderson-Hasselbalch equation, and you should be able to spit it out. pH equals the pKa plus the log of the salt over the acid. What's the pKa? The pKa, remember this equation here? The pKa, just like the pH was the negative log of the hydrogen ion concentration, the pKa is the negative log of the dissociation constant for the acid. We're going to get back to this on a number of occasions. But we want to show you, and in this lecture, we're going to spend some time talking about this equation and how it applies to carbonic acid. But right now, what I just want you to look at is it says pH, that's the acidity of the solution, is equal to a constant for the weak acid. If it was a strong acid, we wouldn't be doing this equation. Is equal to the log of the salt of the acid over the acid. You got 3 unknowns in this equation. And sometimes, if you want to treat this as a ratio, you've only got 2 unknowns. You've got the ratio and the pH. So if somebody tells you what the pH is, and they tell you what the acid is, and you can find what the pKa is for the acid, you know what the ratio of the salt to the acid is in that solution. If they give you the ratio of the salt to the acid in the solution, and you know the pKa, you can determine the pH. You can also say this about this equation. This is really important. If you increase the denominator here, you will bring the pH down because you will make this number smaller. the pH will have to decrease. If you make the numerator smaller, you will make this smaller, and the pH will have to increase. If you increase the numerator or decrease the denominator, the pH has to go up. So you have to get used to looking at this thing and saying, and realizing that if I change either of these or both of them, it's going to change the pH, and you have to be able to predict, if I raise this or lower this, what's going to happen to the pH over there. You might not know the actual numbers. You might just know that the salt of the acid decreased and the acid increased, and be asked what's going to happen to the pH. And if this increases, this number gets smaller, the pH gets smaller. So we'll get back and we'll use this before we finish this lecture.